Alright, so we will learn about three more learning outcomes, okay, which is angle between two planes and angle between line and plane. And the last one is point of intersection between line and a plane. Yeah. So we move on to the first situation where we want to find angle between two planes. So whenever you have a plane here, you must remember that you always have a normal vector which is perpendicular to the plane. So from the formula, so theta equals to cos arc, you have a vector which is n1 and n2 for plane 1 and for plane 2. So dot product over its magnitude of n1 and magnitude of n2. Okay. Alright, so as you can see from the diagram, you have the normal vector. Okay, so here I draw again to make it clearer. So we have the vector of the normal n1 and n2. That is how the theta, the angle between two planes work. Okay, just use this formula. Okay, so now we move on to how to find an angle between line and plane. So as you can see from the diagram, okay, the normal line is always perpendicular to the plane, right? So it's 90 degrees. We want only the theta. The theta is actually the angle between the line and the plane, right? So we want the theta. So that means the perpendicular angle, the 90 degree minus cos arc. So the n means the normal of the plane, dot with the v. V is the vector of a line, okay, and then divided by its own magnitude. And then we have the point of intersection between line and plane. You must remember point is intersection is we need to find the x, y, and z value. So we'll use these two equation to solve by simultaneous equation method. Okay, so that one is point of intersection. So we move on. Example 57. Two planes pi 1 and pi 2 are defined by. So we need to calculate the angle between the plane pi 1 and pi 2. So here you need to remember, you need to find where is your vector. Where is your vector normal? So from the first plane pi 1, from the formula r dot n equals to a dot n, you know that r is equal to x, y, z vector. And what is n? Of course, n is 3, 1, and negative 4. Okay, in this case, for plane pi 1. So normal equal to 3i plus j minus 4k. And for what is the vector normal for pi 2, the plane pi 2? That is 4i minus 3j plus, what is that? That is 1k. Okay, so this is actually k. So we use the formula angle between two planes. So cos arc n1 dot n2 divided by magnitude of n1, magnitude of n2. So we already get the value of n1. So just substitute into the formula. Remember, when you are doing the dot product, you must have a scalar value. Right, so over modulus of n1 here, so we have 3 square plus 1 square minus plus negative 4 square. And then for n2, we have a set of 9 square plus negative 3 square, and then the last one is 1 square. Okay, so from here we need to solve this equation. So solve this equation. Okay, so I think you will get the same answer with me, right? Okay, the answer should be 78.9 degree, or your answer can be in radian. but make sure you calculate it in gradient mode. Okay, so we're done example 37. Right. So move on. Um, some mistakes I made there. Yeah, it's at 26. Yeah. Move on to example 38. Find the angle between the plane and the straight line. So remember what I told you before? The formula will be when we draw a plane here, we have a normal vector and also line. Yeah, the line will contain a vector, and then we have a normal line which is perpendicular to the plane. But we only find the theta, but then you need to minus with 90 degrees to find the theta. This is the same formula. We need to detect where is our vector. So the normal vector for the plane here, of course, again, r dot n equals to a dot n. So for sure, your n must be 13i minus 3j plus 11k. Yeah. For the line, formula is r equals to a plus tv. So whenever you have a t, then you have a v. So here is lambda. So that's how your v works. So your v is 2i minus j plus k. Right, so we apply the formula. The theta is equal to 90 degrees, sorry, minus cos arc. So n dot v, because n is actually a vector, normal vector. So we just plug in what is the value of normal vector and also the vector of the line. Alright, so divided by its modulus. Okay, and then the final answer will be like this. And I'm sure you'll get the answer. It's very well. So remember the dot product, you must have a scalar value. Okay, you calculate for the magnitude value of n and magnitude value of the vector of the line, so you get the angle 70.8. Right, so move on, example 39. We have a straight line and a plane here. Find the coordinates of point of intersection between line and the plane. Okay, so from here, alright, so here again, I write down the plane formula. So here is the line formula. So I plus j plus k equals to lambda 2i plus 3j minus k. It comes from the vector equation r equals to a plus tv. And then we have a plane equation. R dot n is equals to a dot n. So insert into the formula. So r dot 3i minus j plus 2k is equals to, it's a dot n is equals to 11 scalar. So remember that we want to find the point of intersection. That must be the coordinate of x, y, and also z. So I start from the equation of the line first, which I denote as equation 1. So from equation 1, r is any point, so its vector is x, y, z vector. So a is ijk, so it's 1, 1, 1, and then plus the lambda. And then the vector is 2, 3, negative 1. And then we're comparing, so we get x equal to 1 plus 2 lambda. And then we have y equals to 1 plus 3 lambda. And the last one, z equals to 1 plus, minus lambda. Okay, so from this equation, we are going to find the value for lambda. Then we insert back into the equation of x, y, and z. So we insert x, y, and z into the equation of the plane. Can you see there, equation of the plane? So I expand the equation of the plane. Here is dot product. So r of the plane will be equals to x, y, z. Okay, and a dot, and then we have the n, normal. So 3, -1, and 2 is equals to 11. So I dot product this, the left hand side will get 3x minus y plus z equals to 11. So I insert the x, y, and z value to get the lambda value. Alright, so can you calculate for the lambda value? I'm sure you can calculate it very well. So here the lambda value will be equals to 3. Alright, so we already get the value of lambda. Then the final way is to determine the value of x, y, and z by inserting the lambda value. So x is equals to 1 plus 2 times 3, we can get answer 7. And then y is equals to 1 plus 3 times 3, then you get the value. Oh, actually, okay, some of the question might have mistakes here. Okay, so sorry, we can make correction. Okay, so for y we get 8, and then for z, I think z also we have some error. Okay, so look back at the z equation there. Okay, so z, what is z? Okay, z is actually 2. 2k. So that is 2 to 2. 2 minus lambda and 2 minus 3, which is equal to -1. And final answer is 7, 8, and -1. That is the point of intersection. Alright, so move on to example 40. Here also we want to find the point of intersection between the plane and the line. So what is different between this one? We need to find x, y, z. It's already given in the Cartesian equation of a plane. But now we want to compare with Cartesian equation of a line. Right? So here Cartesian equation of line has t as the subject. So t is equals to x minus 2 over 3. So we want our x as the subject. So 3t is equal to x minus 2. And then x as subject, so we get 3t plus 2. Alright, so from the line, t is equals to y plus 1 over 2. That is for Cartesian equation. So 2t equals to y plus 1. And then y is equals to 2t minus 1. And then lastly, for Cartesian equation of z, okay, so t equals to z minus 3 over -2, so if 2t equals to z minus 3, so z is equals to negative 2t plus 3. So we already get the value of x, y, and z. Alright, so we insert the value, the equation x, y, and z into the Cartesian equation of a plane to get the value of what? The value of t. Okay, so I'm sure that you know how to calculate the value of t, right? So it's okay, I will calculate it for you as well. So let us calculate the value of t. Alright, so what is the value of t? Okay, so 60 plus 4 minus this one, and again, and then calculate everything. Negative 80 is equals to, I think, negative 16. So t is equals to 2. So you already get the value of t. Can you find the value of x, y, and z? I'm sure you can find this one. It's very easy. Alright, so plug in the value of t into x, y, and z value. So that's why you get the answer. So 8, 3, and lastly we get 1. -1. So final answer is 8, 3, and 1. Alright, so for past year question, yeah, I want you to do by yourself this one. So I will upload the solution in the portal. So if you know if you want to check the solution, then you can check it from my portal. Okay, that's all. Thank you.